Hi folks, we're now going to take a look at completing the square for a quadratic where a is not equal to 1. So we're going to consider all possible examples: y equals ax squared plus bx plus c. Okay? And not surprisingly, we're going to try to relate it to completing the square when a is equal to 1. So we're going to go right into an example here. So let's take a look at the first example, which will be y equals 2x squared plus 12x minus 5. Okay, so we know how to complete the square when the a value is equal to 1. So now guess what we're going to do? We're just going to make the a value equal to 1. The way in which we do this is going to have to be by factoring out the coefficient of x squared. Okay. Now, as we saw in the past, this c value, we only ever really deal with it at the very end. So I'm not even going to bother factoring it out of the c value. I'm just going to work with the first two terms. Okay, and that's the main focus for completing the square, is always to work with the first two terms. So I'm going to factor out this 2. Okay, now I'm using square brackets here because I know eventually I'm going to need the round brackets to achieve my perfect square. So if I factor out the 2 from the first two terms, we end up with x squared plus 6x. And then, of course, we always have to keep that minus 5. But now we have a quadratic similar to the ones that we completed the square for before. In other words, we can just apply the exact same process as we did earlier. So here, I know I need my x squared. Recall that we need to write the coefficient of x as 2 times some number. So in this case here, 2 times 3x. Remember that that becomes our h value. And then we need a plus h squared in order to get the trinomial that factors to perfect square. So I'm going to add 3 squared. And of course, as soon as we add something new to an expression, we also have to subtract it so that we don't actually change the value. Okay, and we see that we have exactly the scenario that we had before. So the first 3 terms here just factor to the perfect square x plus h squared. In other words, x plus 3 all squared. And then we still have this minus 9. So we've now managed to create the perfect square. However, we still have some algebra to do because this isn't quite vertex form. So now what we're going to do is we're going to reintroduce this 2, and we're going to distribute it to the 2 terms in this square bracket. So I'm going to multiply to the first term, x plus 3 squared, and multiply to the second term, the minus 9. So what we end up with here is 2 times x plus 3 squared. Then 2 times negative 9 is minus 18. And then, of course, the minus 5, which will now incorporate into our final answer, which is going to be 2 times x plus 3 all squared. And negative 18 minus 5, negative, or minus 23. Okay, and we have vertex form. So again, we see that the a value is the same as it was in standard form. And we can read off the vertex as negative 3 and negative 23. So just a couple of things to keep in mind here, a few things to be aware of. Just make sure you don't accidentally distribute the 2 into this bracket here. Now, why can't you do that? And it all has to do with bedmass. Remember that the exponent takes precedence over this multiplication. So same thing here. Sometimes that's a common mistake. People accidentally distribute the 2 to every term in this bracket. Again, can't do it because of the exponent 2. Exponent takes precedence. And in any case, you'd like it in the form x plus or minus h all squared in the bracket. Okay, so now we're going to take a look at a second example. Okay, so the second example we're going to look at is y equals negative 5x squared plus 22x plus 1. Okay. Now, something that's a little different from the first example is when we looked at the coefficient of x squared 2, it was also a factor of the b value. So it factored out quite nicely. Here, though, we see that negative 5 is not a nice factor of 22. However, we still need to achieve x squared on its own, so we have no choice. So when you're completing the square, you're always factoring out the coefficient of x squared, regardless of whether it's a common factor between the first two terms. So again, let's factor out the -5. Okay, so here we're left with x squared. Now again, we want x squared, not negative x squared. So if the coefficient a is negative, you have to factor the whole thing. And now, when we factor out a -5 from 22, well, you just do 22 divided by -5, and you end up with minus 4.4x. Okay, and again, we're not going to bother doing it with the 1. We can just deal with that later on. We really just need to focus on the first two terms. Okay, and again, when you look inside that square bracket, you see exactly the format that we had from the first video. So here, -5, and now let's set up our development of our perfect square. So we have x squared. We need to write this as 2 times some number, and in this case here, it's 2 times 2.2 times x. And now we have to add 2.2 squared. I'm actually going to write it out directly. And 2.2 squared is 4.84. Okay, we added 4.84, which we needed to achieve our perfect square. But since we've added something new to the expression, we also have to subtract 4.84 to make sure we don't actually change the value. And then, of course, plus 1. So again, we continue just as before. So the first 3 terms give us our perfect square. In this case here, x minus h is x minus 2.2. And here we're left with the minus 4.84. And then, of course, the plus 1. And now we need to get it into vertex form, so we have to distribute the -5 to both expressions in the square bracket, and we end up with -5 times x minus 2.2 squared, and then -5 times -4.84 is just 24.2. And then our last step is to simplify everything, and we have -5 times x minus 2.2 all squared plus 25.2. Okay, so that means our vertex here would just be 2.2, 25.2. Okay, so again, let's just go over the main steps when completing the square where a is not equal to 1. The first step is to factor out whatever the coefficient of x squared is from the first 2 terms only. That is, from the x squared term and the x term. Okay, leaving the c value aside. Then what's left of the first 2 terms, once you've factored out the a value, you then complete the square as we did before. Okay, so give a few of these a try, and again, this is a process. It's always the same thing. There's no creativity involved. It's just about following the process.